this is not a speech like that. It's just, I'm sharing a couple of thoughts with you, and please feel free to ask questions. I'm trying to get that through in 1 hour, but we can easily go on some other time. So let's dive into it. Can you see my screen, Rob? Is everything okay?
Yeah, Martin, things look good. We can see your picture of you, so scholarly there with those glasses on your nose, and we see your screen is perfect. Thank you.
Super. And you don't see my controls, do you? Okay.
No, well, I don't know what you mean by your controls. We just see the screen. We see what you're seeing. So you just reduced it. We now see the background of your computer with the Hawaiian scene.
All right, I'll make it a little bit more convenient. Okay, let's start. So, right, topic tonight, and keep in mind, this is functional human biology. It is not anatomy or physiology. Stress, sleep, and neurofeedback is the topic. Now, the purpose tonight is I'm not going to give you much new information. I believe we all have our heads full with details. However, what I'm attempting to do tonight is to connect the dots, which enables us all to create insight and understanding, which is a very personal thing to do. You cannot learn that at school. So let's dive right into it. Questions we're going to discuss tonight is, what is stress? Does stress affect sleep? And if so, why? Remark, not how, why? And further, what can we do about it with neurofeedback as a conclusion? Before we get there, let's tune in a little bit into a specific train of thought. The scientific fundamentals, my favorite scientists of all, Aristotle's principle of infinite incompetence. Keep in mind, I cannot know what I do not know that I don't know. And this led Aristotle to a very specific way of doing science, which is a little bit different from what is fashionable today in academia. The procedure is very simple. Ask a neutral question. Avoid any assumption. Do never conclude, but deduct logically, which is not the same. And finally, find a non-judgmental, strictly logic answer. In other words, with information or knowledge, create understanding. So let's do that right now and ask the scientific questions which are fundamentally important. Very general, not only with respect to sleep or stress. One of the fundamental questions is, how is something built? This is a question after its structure. With respect to human organisms, this is anatomy, which is, in fact, just a huge catalog of building parts of the human body, which in itself does not reveal much. The second fundamental question is, how does it work? With this question, we're looking into biodynamics. We want to find out what biochemical, mechanical processes are going on. And the science who does that is called physiology, which reveals, as a result, a huge catalog of biochemical processes. So now we have this building plan of an organism, and we have its range of biochemical operation, anatomy and physiology, but it does not tell us anything about what happens and why. This question goes for function and purposes. And the science behind it, founded by Aristotle, is called ergonomy. It is the fundamental basic science of functional biology. Ergonomy allows you an understanding of biodynamics. In other words, cell, organs, organisms in function, in action, with their particular anatomy, employing their physiology to do some action. So what we basically look at today is, we ask the questions, help, can anyone show me how to operate this thing? The primary question we ask is, what is stress? With this methodology in mind. In order to get there, let's recall some real fundamentals of functional biology. What is a live organism? A live organism is a biological structure that has a task, and the task is very simple: physically exist. It's less easy than we think to achieve that. It requires continuous activity. The means a life organism has is a continuous active interaction with its environment, primarily in a molecular dimension. For instance, withdraw oxygen out of your environment permanently and exhale carbon dioxide continuously. If you stop doing this, you're out of the game. And the action to keep yourself in shape is a continuous activity of self-build, self-maintain, self-repair your organism according to its specific genetic blueprint. This is the continuous activity we generally call living. It is also the biological definition of behavior, which is perform the activity of living. A live organism has only two possible functional threats. One of them is lack of material, resources, to successfully continue the activity of living. We call those suffocation, starvation. The other possible threat is physical damage or chemical damage to the anatomical structure, which leads to disintegration by internal or external forces. So keep yourself alive is the continuous action of dealing with these two possible functional threats. There are two primary systems, life systems or life principles we can observe in nature of threat coping. The so-called organism modus operandi, which of course requires a specific, the respective specific anatomical design. One of them is chosen by plants or fungi, is the principle of stability. The organism is built in a way which allows extreme energy efficiency, very high tolerance of varying supply, of variance in supply, and which focuses on a static and biochemical stability, high injury tolerance. You can continue to cut branches off the hedges in your garden. The plant doesn't die. Try to cut fingers off of a human being. Not very healthy. So the stability principle requires a substantial strain tolerance. Animals and humans, on the other hand, are built after a completely different life principle. It's the principle of mobility, which allows a human organism, for instance, to actively acquire resources. It can actively act to avoid potential threats. However, and that's why we slowly get close to the topic stress, it requires anticipation of threats. A plant does not have to do that. It can sustain strain. An animal which has a mobile organism has to pay the price for mobility, which is extreme vulnerability. Flexibility of the organism causes laws of physics, extreme vulnerability. So let's look at what is stress. The definition of term stress is very simple. It's the strain a force executes on an object. Plants and fungi, for them, this is true. Their anatomy is built in a way that it can passively withstand considerable strain. Remember, the organism's modus operandi is static, biochemical, and thermic stability and sustainable injury tolerance. Animals and humans, however, for them, this definition is definitely not true. They cannot allow strain of a force to act on their organisms, else they are damaged. Their mode of operation is act, move, behave, because you must act to prevent strain to the organism. Does anyone have a question so far? So for us mobile creatures, animals and humans, stress isn't a force executed on the organism. It is something entirely different. It's an activity. It's the activity of preventing strain to act on the organism. This is true not only for us humans, it's for any mobile creature on the planet. So, what does that mean? We must be capable, able to identify any potential threats before they act. We must evaluate their severity, and then we must preemptively act to avoid any strain on our organism. In other words, we must execute coordinated activity, motion, or behavior with the purpose to prevent damage to the organism. Note, for us humans, stress isn't a problem, it's an activity. The term stress, as I said, is preventing strain on the organism. It's non-negotiable, a vital activity in order to live. And we must execute this activity non-stop, all life long. In order to be able to do that, we require a built-in organ that does the job, which is, as a responsible executive organ, our central nervous system. That's what the brain does. Now, the job of actively preventing strain on the organism is quite a sequenced data processing achievement. And it consists of several steps which all depend on completion of the previous one. First, our central nervous system, our brain, has to identify potential threats. This is always subjective, because one threat to one organism can be no threat of food to another. We also must identify the present action potential of our organism. Are we fully operational, or do we suffer from any sort of reduced capability that may make us slower or make us reduce the force we can execute? Because depending on our potential, we need to act differently. Then we must decide action priority. There might be more than just one single isolated stress. So we need, and we can act only on one. So we need to decide which threat to actually, or potential threat to actually counteract. We also must decide how urgently it is. That's what our brain does, non-stop, all life long, awake or asleep. If it stops doing it, you're out of the game. Next step is the commanding parts. We need to prepare the organism for a specific action. In other words, we need to command the physiological arousal of our organism, which allows the organism to act in a specific way. We come to that a little bit more detailed later. And lastly, our central nervous systems must direct the execution of an action, the actual behavior, which results in an activity of an organism which is assumed, not granted, to prevent threat. Quite a job. By the way, this is the primary reason why every mobile creature on the planet must have a central nervous system. And that is why you and I have a brain. Let's look at some steps of that sequence, the data processing job of our central nervous system: decide, action, priority, and urgency. We have long-standing information about what is the actual background of this priority setting. Abraham Maslow, with his famous pyramid of needs, was probably not aware that this is a priority guideline for the human central nervous system. Any question to that? If a threat is on the lowest level, imminent physiological danger, that has priority over everything else and must be attended to with respective action. If our safety is in danger, that has the next lower priority, and so forth. The last priority, the last two, are social integration and self-fulfilling activities. The activity of preventing strain on an organism is still what we are looking at by finding answers to what is stress. Decided by its design of the anatomy, each organism has a possible range of operation. Within this range, its physiology functions. The sequent data processing step the brain now must do is it must prepare the organism within that range to be able to execute any action which potentially counteracts any threat. Let's look a little bit at this maximum and minimum thing here on the screen. We have our organism has two extremes. It can either develop greatest speed, the maximum force and fastest reaction to the price of extremely high energy consumption, resulting in greatest exhaustion and maximum wear and tear of the organism. Or in the other extreme, it can be most efficient in recovery work, healing, digestion, processing food, immune work, memory rebooting, and so forth. However, that can only happen if the organism is put into a state where it is non-responsive, does not need its motor system and external tension system, for instance. It's non-responsive to environment and immobilized. In this state of function, the organism is extremely vulnerable, just because its response to any threat is practically impossible in this state. So the brain must, at any given moment of life, always assess possible threats and put the organism into the state where it can actually take action to counterbalance the threat. At any moment of life, we are always somewhere in between activation to maximum agility, highest speed and force, or the other extreme, a state where our restorative activity is at its best. Both states cannot be maintained for long. I doubt whether they ever can be really reached. During a day, we always fluctuate between these two limits of our possible range. And again, it's defined by our anatomy, and it is possible or defined by the limitations of our anatomy given to physiology, the biochemical and mechanical processes. Let's quickly look how the brain can, I'm not going into detail with this table here, but let's quickly look at the means the brain has to actually command one of these states. The brain has very limited command tools available actually, and sits locked up there in the head office up there. It cannot do it himself. The brain depends on a command infrastructure. The direct infrastructure available to the brain are just two things. The brain can produce brain waves, which is a radio broadcasting, global, same message to all individual cells of the organism. It's an electromagnetic command tool. It's instantaneous with the speed of light, and it's contained. It's actually enforced by the fact that the body is electromagnetically a Faraday cage. The other means of operation or command the brain has is the peripheral nervous system. Unlike the brain waves, this is a targeted intercom network. It goes point to point to individual organs or parts thereof. It's bioelectrical, it's fast, the speed is regulated, and it allows opposite commands to different parts of the body. One muscle, pull, the other muscle, let go, simultaneously. Using these systems, the brain has indirect control over the hydromessaging system, which is part of our human body, which is the endocrine system. The brain can control or command the output of a great variety of different glands. It can tell one gland to produce or to release a certain chemical and the other one to stop releasing. In this way, the brain is capable of directing a very specific endocrinal soup with a very regulated analog regulation. He can command at any moment a specific spicing of our blood. This allows a global, entire organism, delayed, it takes time to produce that message to the entire organism. And the mechanism is not bioelectrical or electromagnetic, it's biochemical. It's slow, but it's relatively persistent. It takes a while until this particular spicing of our blood is altered or washed out. And the primary means is density regulation. So a little more of this spice increases the density of it. A little less of another spice reduces the density of it. With these command tools, the brain is able to control to a high degree the thermic, electromagnetic, acidity, bioelectrical, biochemical, and pressure environment of each specific cell. And remember, to form a human organism, there are about 40 trillion of them. I don't know who counted them. It would probably take about 10,000 years, but it's an estimation. So it's important, if we want to really understand what stress is, it's very important that we just have a clue of these mechanisms, not the physiological details. They are irrelevant, but the functions those things have. By the way, the hydromessaging system also requires a distribution system, a carrier, the entire cardiovascular system, which also must be regulated by the brain directly via the peripheral nervous system. So the brain makes a threat assessment. What is out there that could potentially put myself, my organism, into danger? Am I running out of resources? It assesses and judges the importance and the urgency of the total of all perceived and assessed threats, and then releases a command which can only put the entire organism ready for one specific action. This could be run away, hide, play dead, go to sleep and repair. In this range of operation, the organism can do only one specific thing. You cannot sleep and be awake simultaneously because of this mechanism. So with this mechanism, the brain always, at any moment of life, commands a particular mode of operation of the organism. If we are awake, we have our external attention system activated. It's an endocrinal agility motivation, adrenaline, noradrenaline, etc., etc. It activates the motor system and its subsidiaries. Motor memory is activated. Object recognition, navigation is possible. That's the activation side of our physiological mode of operation. On the other side, we have the internal attention system activated. Endocrinal restoration activation. Melatonin is released on command of the brain, dopamine, etc. The gastrointestinal system and its subsidiaries are activated. The immune system is activated. And memory is partly taken offline, cleaned up, in order to allow functions like learning, forgetting, and trauma leave, etc. The thing is, they cannot happen simultaneously. This is very important to keep in mind when we think stress and sleep. Remark on this little scale, in a small mid-range here, we have the best mental performance. Energy for mental activity can only be freed if it isn't required to be speedy, powerful, and fast, and is not required to go deep and do repair work. So in that mid-range, there is a range where our conscious awareness, thought, logic is possible and best. Also intuition, creativity, and dreaming. All this is carefully controlled by the central nervous system. If that wasn't the case, our ancestors couldn't have survived a split second. So, does stress, which we now know is an activity and always causes a very specific endocrinal soup, which does not allow the organism to do certain activities and enables the organism to do some other activities, does that affect sleep? And if so, why? What is sleep? Sleep is one half of the antagonistic functional subrange the organism has available to respond to threat. It is that subrange which deals with internal functional threats, such as having to restore, having to repair, having to reboot, and so forth. So, does sleep affect sleep? Does stress affect sleep? If the brain commands this state of physiological functioning of an organism, the organism is extremely vulnerable. It's non-responsive, it's immobilized and paralyzed. In order, the more paralyzed, the less responsive, the more efficient is restoration. So, if the brain assesses a high load of anticipated threat, it will never ever command an endocrinal soup which paralyzes the organism. Because the mode of operation of us animals and humans requires activity to prevent strain to the organism. If we sleep, we are desactivated. High stress load and requires activation, and we must be awake to be able to act physiologically. So yes, my conclusion, you come to your own, but my conclusion is there is no question that stress does affect sleep. And it's also not possible that it does not. In fact, stress is the only physiological phenomenon that actually has the power to affect sleep. Now, what happens if our stress load, in other words, the high and the low, high load of anticipated threats, which they haven't been affected yet, they are anticipated. What happens if this load is so high that the brain does not put us asleep? On this graph here, we look at what happens to our agility potential throughout the day and what is required in terms of activation of the organism to maintain a stable performance. The highest potential to act has the human organism has when it gets up after a period of restoration is relatively highest. Just by being awake, just by being considering the environment, responding to the environment, resources start to deplete. Walking around and go and get resources costs a lot of energy and does not produce the resources the body needs. They need, the food we eat needs to be processed first before it becomes available. So throughout the day, the maximum output in terms of force and speed a human organism can produce throughout the day must decrease over time. We call that exhaustion. In order to maintain a specific performance, the brain must command an increasing arousal level until the organism reaches its fatigue point. That is the point where even a higher arousal can no longer maintain a given performance. When we reach that fatigue point, in order to at least maintain the maximum possible performance, the brain must command an even increasing physiological arousal. And that leads, after a certain time, to something we could define as over-arousal, which is reciprocal to the excessive wear and tear and exhaustion. The same thing happens. So the fatigue point is the point where, under ideal conditions, the brain would switch the physiological state towards restoration, deactivate the organism, start restorative work, which can never be done simultaneously. In other words, we would doze off and fall to sleep at the fatigue point. How does that look in terms of sleep research? Most of you probably have heard of the famous hypnogram, which is a graph of a sequence of sleep cycles, which are circadian rhythms, which last for humans approximately 90 minutes each. Now, circadian rhythms, since they happen when you're asleep, fall into the lower half segment of the range of physiological possibilities. At the fatigue point, sleep cycles start to kick in naturally, ideally. One sleep cycle is, we could imagine, just a maintenance round on the entire organism. The organism goes through several stages there. At times we are completely paralyzed, completely non-responsive to environment. At other stages we dream, we have pretty high mental activity, which shows on this graph. That's when we get close to that area, that physiological area, where mental performance is possible. And in terms of function, there is no difference between conscious awareness and thought and intuition, creativity, or dreaming. It's the same process, which is exclusively memory-based. But I'm not going into more details here. Let's look at what happens if we carry our organism in an over-aroused state. into the time we actually want to go to bed and want to start sleeping. What over-arousal causes is it upshifts the entire hypnogram into the awake state. And the graph here demonstrates very, very clearly almost any imaginable sleep issues people come to clinics with. Because now those sleep cycles are upshifted into the best possible mental performance range, we experience racing mind. We wake up and experience a racing mind, mental rumination. We also experience delayed onset of sleep. We experience very shallow sleep cycles. No wonder it's upshifted. We experience little or no REM sleep at all. No, we are already awake. We are too high in our arousal. And we also experience frequent and prolonged awake peak periods, because instead of being just close to being awake, which is an important function of a sleep cycle, we are now fully awake. We experience incomplete sleep cycles, premature wake up, and of course, a substantial loss of restorative efficiency. And the only reason is stress. And to be precise, what it is actually because of an extremely high load of anticipated threats, the brain does not dare to put us in an even more vulnerable state. Because the only thing a human organism can do to counteract threats is act, be awake. So now comes the final question. What can we do with neurofeedback about all that? Let's go back to what happens throughout the day. Throughout the day, I just recalled, agility potential of the organism must decrease due to exhaustion and wear and tear. And inverse proportional, the required physiological arousal must increase. Our modern lifestyle for almost all of us, forces us to actually go across beyond the fatigue point where we naturally just would doze off, at least for a moment, and have a nap. So we remain active, which leads to an overarousal, and as we have just seen, to all the entire set of sleep issues we can possibly imagine, due to the overarousal at the time we are finally scheduled to go to sleep. So now we introduce a neurofeedback session into that day. First of all, the session has much more impact than just running protocols. One of the impact is the client stops performing while he's sitting in a chair. So this gives an interruption of the performance drive that client would experience without the neurofeedback session. It gives him a break. In addition, if the neurofeedback session is targeted to entrain relaxation, we have a recovery period during the session, which leads to the following effect. It increases the performance potential of the client during the session. So the client gets off the session with a much higher performance potential than without at this particular moment, no matter at what time of the day this neurofeedback session happens. Since this is an inverse proportional necessity, it also decreases the arousal level during the session. Consequently, the onset of reaching the fatigue point, the client reaches the fatigue point later than without the session, no matter what he goes through the rest of the day. Always compared to without session, of course. So the first and primary direct impact a session has is it's a relaxation entrainment. which automatically slows exhaustion during the session. And it indirectly slows the increase of the required physiological arousal to keep performing after the session. It actively entrains the organism to relax, de-arouse. It indirectly delays the crossover or fatigue point further back towards when he goes to bed, which contributes to the lower arousal at the intended start of sleep. It dips the hypnogram down to where it belongs after this at the night following this particular session, and that increases the restorative sleep efficiency granted by the laws of nature. Now, if that client went to bed with a dipped back, more efficient sleep period, he will wake up the next morning with in a much better restored state, which decreases the amount of arousal he or she will have to produce in order to do a given performance. So this is a very direct and absolutely logical process if the neurofeedback session does not entrain performance, but relaxation. With this, I basically reached the thoughts I would like to share with you today. I can quickly conclude stress for us humans is not produced by external effects or events or a life situation or finances. It is an activity. It's a stress assessment produced by our brains, a threat assessment, and all threats are anticipated threats. So there is a large memory component, life experience component involved. That's why trauma can be extremely stressful. In other words, the brain of a brain with a traumatized memory experience considers the world as more dangerous than the brain of someone who isn't traumatized. In other words, it remains a very high stress response capability physiologically. In other words, it keeps the traumatized brain must, based on its available information, keep the organism physiologically aroused more than someone who has a non-traumatized brain. So, the trauma relief thing happens automatically. The brain has an absolute affinity towards relaxation. The only thing, and the organism too, if you don't have to move, you don't want to move, because it causes damage to your organism. So damage in form of wear and tear, damage in form of excessive use of resources, which you will have to go and replenish again and reprocess again. The ideal state is non-mobility. That's the affinity state of nature for mobile organisms. However, because they're forced to anticipate possible threats, identify them, judge them, evaluate them, because they need to act before threats can become active. This is a continuous process which goes on. There is never a moment of life without stress. However, what varies greatly is the evaluation, or let's say the value this stress can have. And that's where we kick in, where we can kick in with neurofeedback. Indirectly, the most efficient way to deal with stress and sleep issues is deal with stress by entraining the client, by providing the client with a time, number one, which offers the most stressless possible situation. Encourage the client's brain to go into a relaxed state, which means become active in restoration. The brain never sleeps, the organism never sleeps, no single cell ever stops being alive. But what they do is they change between restorative activity and exhaustive activity. So the more we entrain a client's brain to be able to fast go into a restorative state, the more efficient the client becomes in it. And the secondary effect is that day of a neurofeedback session, absolutely granted by all laws of nature, that client dips his sleep hypnogram down and has a more restorative sleep, as compared to the same experience after the session without the session. Does that make any sense? So, does anybody have any question to this respect now? I'm basically done with my presentation.
Okay, anyone, questions? Comments?
Did we lose did I bore the audience to death?
I think you bored him to death, Martin.
I think so, but it's it's excusable Monday evening.
Yeah.
Well, what do you think, Rob? Does that make sense, what I'm presenting here?
It's good information, Martin. I think it gives people, I mean, the way I look at what you were doing is you're trying to pull a variety of factors together that, what ultimately can affect our sleep, and looking at it from a stress model is an important way of looking at it. So it's not a simplistic task as you so clearly point out. I mean, one system is connected to the other, so everything we do essentially affects the outcome of who we are as people, how we, from day to day function and behave, and all that's going to affect sleep. It's just gonna. I was sitting in my sister's here visiting, and she's dealing with a lot of stressors in her family with one of her grandchildren, and she got a phone call, and as soon as she looked at who the phone call was from, she burst into tears. It was just a phone call message, but she knew what it was dealing with. So I mean, I said, you're wound tighter than a drum. Well, people like that don't oftentimes sleep too well.
It's not possible.
So I think you did a nice job trying to pull together various aspects. Richard?
Yeah, it was good. It was a good comprehensive integration of a lot of the stuff that we talk about, and giving it a fresh perspective. It's a lot of good stuff to think about, Martin. I really appreciate your presentation. It was very good.
I address it also to you, Richard, because I know your really deep insight into the understanding of psychological effects. What this here is, it's actually a bridge between psychology and functional biology.
Yep. No, that's good. That's good. That's because many of us are psychophysiologists, and not everybody studied psychophysiology when they went into neurofeedback, and so these are pieces of that. What you have to study and to be biofeedback certified. So it's very nice.
Yeah. Beyond that, one of your favorite themes, Richard, is the self, right?
Yep. Mm-hmm.
So, what is the self? The self is biologically required to identify inside and outside of your organism. See, so in order for the brain to be able to make a stress or a potential threat assessment, it requires a self. The concept of a self.
Absolutely. Some
Martin?
Yes?
Oh, hi. Can you hear me? This is Bree.
Yeah, Bree. How are you doing?
Hi. Wonderful presentation. Thank you.
Thank you, Bree.
Hey, could you give me, this comes up in my work all the time with trauma.
Yeah.
And could you give me the synopsis of what you were saying regarding trauma? And I'm assuming you were thinking alpha theta in, large part for the relaxation.
Absolutely, yes. You got me there, Bree.
Yeah. And so in terms of, I know all the amazing effects of alpha theta on, helping the brain to clear fear and trauma. And obviously, sleep problems are huge with trauma. But if you had to encapsulate all that in 1 or 2 sentences in terms of neurofeedback, trauma, and sleep. Could you repeat that for me? That would be great.
Yeah, absolutely. That's no problem. I mean, first of all, there is no fear without the brain having assessed that you're under threat. Would you agree to that?
Yeah.
Okay. Now, keep one thing in mind. This is a very subjective assessment by a particular brain. It's not valid for everybody. It's just very personal. So what makes you define what is a threat and what is not? No situation, no happening out there is naturally, by definition, absolute a threat. It's
Right.
just a situation, neutral. So the brain must, in order to keep you alive, assess a happening, and it has to have a reference to find out, is it dangerous or not? And the only reference the brain actually has available is life experience. So is a particular situation or event compared to my personal library of events and outcomes, is that a potential threat? See, that if it is, it creates, hopefully, anxiety. So if you're loaded with what we call trauma, which is just a very severe life experience, okay? If your library has a lot of these dangerous events, in order to make sure that you are not harmed by a potential threat, you need to act much earlier. Start running faster. Okay?
Right, yeah.
In other words, you need to increase your physiological readiness to run faster.
Your vigilance.
Yeah, the vigilance, exactly. And the entire, fear is a huge complex of different, and can have different observable phenomena and behavioral consequences and so forth. But fear just means the brain has assessed that there is potential threats to a very high degree. Mm-hmm. And the best way to deal with that, right, is to actually demonstrate to a particular brain that right now there is no threat. Mm-hmm. So if you do that with your neurofeedback session, right?
And alpha theta in particular.
There's more. There's much more which is important, right? The client walks into your office and continuously starts to assess your threats, his threats, potential threats. Mm-hmm. So, if you look friendly and calm and have a low heart rate when you meet your client, that is considered. If the client, the environment of your training is extremely important. It's the primary foundation. If the client doesn't feel safe in your hands, no protocol whatsoever can be efficient. Make sense?
Good point. Yeah. Yeah.
Okay. Then yes, alpha theta. Why alpha theta? Okay. The reason is very simple. Empirical. According to Richard's information, according to information I can see, if I compare all these different protocols, that's what it boils down to by experience. In other words, alpha theta can have the effect of calming you down. Nobody knows why, because brainwaves don't do what you train with alpha theta. But that's in this respect irrelevant. As long as it works and doesn't create any harm, that's fine, isn't it?
Yeah, I've noticed that even people who don't get crossovers, they seem to feel calmer afterwards.
Yeah, I do have my wild theories, of course. It wouldn't be me if I wouldn't have them regarding crossovers. I think you stuff. That's my observation. I do practically nothing but alpha theta and SMR. So I start to see a correlation between the simple fact that alpha waves and theta waves go against each other. Like a theta increases and alpha decreases simultaneously. That already is a crossover. They don't really have to cross over in amplitudes as shown on the screen to have a certain effect.
Would good. I like that. Yeah. Yeah.
Okay. So the importance is they don't go parallel. If theta increases, alpha increases as well. but they do the opposite. They either they just go against each other, either up or down. That's a crossover. It doesn't have to physically cross over on your graph to be efficient.
Oh, good. Thank you.
But hey, that's my observation. That's not that there is no research about that. But my experience with alpha theta shows that, as you said, you can have an effect even if there isn't a graphic crossover on your training screen.
Okay. All right. Well, we're getting way past the hour here. Stimulating a lot of conversation. Maybe we can pick up some of this on Wednesday. And
yes, with pleasure. Yep.